In this video, I'm going to explore a technique that is often used in APL to mask out some values of a vector according to a Boolean test. So if this technique sounds familiar to you, and mind you, I'm not even going to use advanced primitives, I'm just going to perform some multiplications with Boolean masks. So if this sounds familiar to you, feel free to skip this video. Otherwise, hang in tight and let's get to it. So basically what I want is to give you a preview of the technique we are going to use to implement the leaky relu activation function. And if you recall correctly, we will need to handle positive and negative numbers separately, because the positive numbers will be left as is and the negative numbers will be multiplied by a small number, which was that leaky parameter. And so let me go ahead and create a vector with some numbers. Let's say -3, -1, 0, 4, 5. And so for the leaky relu, when the 4 and 5 go in, they will be left unchanged, and when the -3 and -1 go in, they should be multiplied by something. And so what we are going to see now is how can I select these numbers? How can I get to these values without messing with the other ones? And well, a fairly common technique, and okay, mind you, this is not one of those, we are not going for the popular approach of looping over the vector, checking if the number is positive or negative and acting on the number according to the sign of the number. In APL, we always strive for array-oriented approaches in which we can process the whole array at once, and so that's basically what we are going to do right now. Usually we start by creating a Boolean mask. B here stands for Boolean. A Boolean mask indicating the positions in which the numbers we want to process are. So for example, we can get the positive numbers by typing in 0 less than v. And you can see we get this. These 3 zeros mean that these are not greater than 0, and then these 2 ones mean that these numbers pass the test. And in APL, we don't have the built-in type for Boolean values. We just use 0 to represent false and 1 to represent true. And this comes in very handy when we want to perform arithmetics. For example, if now I multiply b with v, notice that I mask out the negative numbers and I only get the positive numbers. Or if I do it in a different way, if I take v and multiply it with the negative numbers, notice that now I'm checking when 0 is greater than v. Now I can mask out the positive numbers and I only get negative numbers. And I could multiply them with the leaky parameter. Now I can just do, say, 0.1 times this, and there you have it. The numbers are less negative, quote unquote, of course, and I still have the original numbers here, so I can still get the positive numbers and do something with them. So this is a way of doing that. But there's also something I really like about APL, and that is when you have a specific problem to solve, there's often a very large set of different approaches you can take. So there's always to reinvent. There's always an opportunity to reinvent what you just did and do it in a different way. And we are actually going to see how we could do this in a different way as well. If you type APL S, you will end up typing this thing that looks like an inverted L with a shorter leg. And this function, when used dyadically, gives you the maximum of its 2 arguments. And this is APL S, as in sealing the sound. Of course, sealing is with seal it. That's the main idea, because actually, if the function is used monadically, it rounds up. So APL S either rounds up some numbers or gives you the maximum of its 2 arguments. So if we have v and we want to mask out the negative numbers, that is to say, if we want to turn negative numbers into 0, we can just find the maximum between v and 0, and then the negative numbers are masked out. Similarly, if I want to extract only the positive numbers, I could use the minimum function, which is APL d, as in down, which of course, you guessed it, rounds down, but also when used dyadically, so with two arguments, it returns the minimum. So if I find the minimum between 0 and v, all my positive numbers are masked out, because 0 is smaller than them. So this is another approach one could take. And there's certainly plenty of other things you could do. One just has to know all the primitives that exist, get acquainted with them, and then code whatever approach one prefers. These two are enough for us. Let me just introduce you to a simple APL primitive, which will come in handy, I think. But it's very simple to understand. It's the tilde that you can type with APL T, as in tilde. And what it does is, it takes a set of Boolean numbers, that means zeros and ones, and it negates them. So ones become zeros and zeros become ones. There's nothing simpler than this. This is our usual not operator or not function in other programming languages. Mind you that languages like Python have something that's called Truthy and Falsey values, and that basically means some values can be interpreted as booleans, even if they are not. For example, integers can be interpreted as booleans, and depending on the value of the integer, it's interpreted as true or false. In APL, that does not happen. So 0 stands for false, 1 stands for true, and you can't negate, for example, a 3 in the middle of some Boolean numbers. Not does not know what the negation of 3 is, because 3 is not a Boolean. So bear that in mind. And that's it. Now that we've covered this selection technique to mask out numbers, we can implement our leaky ReLU activation function.